Shear forces in bending moments are internal forces, and internal moments in beams. In the given free body diagram of beam, for equilibrium of this part, a force V and a couple whose moment M must act at the section. The force V and the moment M are the resultants of the forces distributed over the cross-section. In the FBD of the isolated part of the beam, V and M are considered to be external forces. However, for the beam as a whole, they are the internal forces at section X. The force V is the resultant of the transverse forces that are distributed over the cross-section at the section. This force V is called the shear force acting on the beam at the section X. It is an internal shear. The couple with moment M is the resultant of the distributed axial force that acts on the section X. It is called the bending moment acting on the beam at section X. Similar to V, it is an internal moment. The quantity of V and M may be determined by the conditions of equilibrium for the isolated part of the beam. Causes. They are caused by transverse loads and couples. Shear force. Shear force is the force in the beam acting perpendicular to its longitudinal axis, x-axis. Beam's ability. For the design purposes, the beam's ability to resist a shear force is more important than its ability to resist an axial force. Axial force. Axial force is the force in the beam acting parallel to the longitudinal axis. Causes of stresses. Thus, when any structure is loaded, stresses are induced in the various parts of the structure and, in order to calculate the stresses where the structure is supported at a number of points, the bending moments and shear forces acting must also be calculated.